In question 1, we start off by being asked to show that f of x simplifies to 5x over x plus 3. So I will start by writing out that f of x is 5x over x plus 3x plus 4, that's the factorization of the denominator, plus 5x over x plus 4. So we wish to express everything over the same denominator of x plus 3, x plus 4. So this will lead to the denominator being x plus 3, x plus 4, and the numerator I'm having 5x plus 5x brackets x plus 3. I will now expand the numerator to get 5x plus 5x squared plus 15x over x plus 3x plus 4. And then collecting like terms in the numerator will give me 5x squared plus 20x over x plus 3x plus 4. We can see we have a common factor of 5x in the numerator, so it's 5x x plus 4 over x plus 3x plus 4. And then obviously the x plus 4 will cancel out, and I'm left with 5x over x plus 3 as required. So the final answer for part A is 5x over x plus 3 as required. It's a show that question, so we need to show every single step to claim full marks. And then in part B, we need to find f inverse. So based on our answer to part A, we start by writing out that y is 5x over x plus 3. I will interchange x and y, so x is 5y over y plus 3. We can cross multiply to get xy plus 3x is 5y, leading to 3x being 5y minus xy, and therefore 3x is y brackets 5 minus x. So 3x over 5 minus x is equal to y. So we've got an expression for f inverse of x. However, we are not done. We need to state the domain of f inverse, and to do that we need to actually go back to f of x, and I will sketch, and based on that I will derive the domain of f inverse using the fact that the domain of f inverse is the range of f. So we have that f of x was 5x over x plus 3 for a domain of x greater than 0. We've got asymptotes at x is negative 3. This is the point where the denominator becomes 0. So at x is minus 3, we've got a vertical asymptote. For a horizontal asymptote, we say that as x goes to infinity, we say that the 3 becomes insignificant, so y is 5x over x, or simply 5, so y tends to 5. We also see that when x is 0, y is 0. So this curve passes through the origin, so I can draw a pair of axes, and I will try putting all the information I've covered up to now on my sketch. So we've got an asymptote that x is negative 3, and an asymptote that y is 5. So let me label this, y is 5, and then x is negative 3. So it goes like this, or like this on this part here. So what we are looking at is the unrestricted graph of f of x. I will now impose the restriction that x is greater than 0. So when x is 0, y is 0, so we're here, and we're looking for values of x greater than 0, so it's only this part of the curve only. This means that the range of f is values of y between 0 and 5, and therefore the domain of f inverse is all values of x between 0 and 5. In part C, we need to find the derivative in its simplest form and hence state whether f is increasing or decreasing, justifying our answer. So I will start by stating that f of x was found to be 5x over x plus 3. So I will apply the quotient rule of differentiation. So the derivative of the top is 5, I keep the bottom, minus keep the top, differentiate the bottom, and all over the bottom squared. We can see that this simplifies to 5x plus 15 minus 5x over x plus 3 squared, which simplifies to 15 over x plus 3 squared. Now for the second part of C, we can say that since x plus 3 all squared is greater than 0 for x greater than 0, then we have that f dash of x is greater than 0 for x greater than 0, and therefore we conclude that f of x is an increasing function. In question 2, we're being given the graph of f of x here, and we're asked to state the coordinates of the vertex P. We know that the vertex is at the point where the modulus expression vanishes, so at P 3x minus 13 should be 0. So this leads to x being 13 over 3. And if 3x minus 13 is 0, then y is 5, and therefore the coordinates of P are 13 over 3, 5. We are then asked to state the range of f and also find the value of f of 4. So for the range, we can see that all values of f of x belong to the real numbers and are greater than or equal to 5, which was the y coordinate of the vertex. Now to find f of 4, I start by finding f of 4, which is the modulus of 3 times 4 minus 13 plus 5. So it's the absolute value of negative 1 plus 5, which is 1 plus 5, which is 6. And then f of 4 is simply f of 6, which is 3 times 6 minus 13 absolute value plus 5. This is 18 minus 13 absolute value plus 5, which is 5 plus 5, which is 10. So f of 4 is 10. Then C, solve using algebra and showing you're working this inequality here. So we've got 16 minus 2x being greater than the graph. In order to do that, I'll have to go back to my graph and do some preparatory work. So I will start by identifying each line segment with its individual equation without the modulus sign. So on the right hand side, we've got y is 3x minus 13 plus 5, which simplifies to y is 3x minus 8. In other words, the modulus sign behaves like a normal set of round brackets. And on the left hand side, we've got y is minus brackets 3x minus 13 plus 5, which gives me y to be minus 3x plus 18. And then we've got the line y 16 minus 2x. So it's a line going like this. So it's cutting the y-axis at 16. It's easy to see that this cut here of the original graph is at 18, so the 16 is below that, and we need to find the range of values of x for which the straight line is above the V-shaped graph. So I need to find the 2 points of intersection here, and I need to choose the in-between region. So in order to do that, I will be equating the 16 minus 2x with the minus 3x plus 18, and then with the 3x minus 8 in order to find the two values of x. So we have that 16 minus 2x is negative 3x plus 18, leading to x being 2, and 16 minus 2x is 3x minus 8, leading to 24 is 5x, so 24 over 5 is x. So going back to the graph once more, we want the straight line to be greater, so above the graph drawn, so we want to be in between the two values. This was the 2, this was the 24/5, and therefore we conclude that we need to be between 2 and 24/5. In part D, we are told that the vertex of the graph y is a f of x plus b is 420, and we need to find the value of the constants a and b. So let's start by considering the effect of the two transformations. So we've got y is a f of x plus b. So the plus b means we deduct b from x, and the a means we multiply y by a. We know that the original graph had a vertex at 13/3, and now according to the question, the new vertex is found at 420. So we deducted b from 13/3 to give us a result of 4. So 13/3 minus b is 4. So 13/3 minus 4 is b, which makes b a third. And we also know that the y value got multiplied by a, and therefore we've got 5a is 20, which makes a 4. In question 3, we are told that the total mass of gold, capital G, extracted from a mine is given by this expression here, and this is the graph of capital G against T, and we need to find the value of K. Now we know that when T is K, capital G is 0, so we start with this. At T is K, capital G is 0, which means that 0 is 40 minus 30 e to the 1 minus 0.05 k. So 30 e to the 1 minus 0.05 k is 40. So e to the 1 minus 0.05 k is 4/3. I will take a ln of both sides, leading to 1 minus 0.05 k is a ln of 4/3, and therefore 1 minus a ln of 4/3 is equal to 0.05 k. So if I divide by 0.053, that will give me k. So this leads to a value of k being 14.246. In II, it says, hence find the year and the month in which the gold started being extracted from the mine. So we have K to be 14.246, that's the initial time. So this means we've got 14 years and 0.246 of a year, so I multiply that by 12, it turns out to be 2.96, and this is months. Now, we were told that it was initially the 1st of January of 1800, so after 14 years and 3 months, it's March of 1814. In B, we need to find the total mass extracted up to the 1st of January of 1870. So the 1st of January of 1870 corresponds to a value of T which is equal to 70. So I will be substituting T is 70 into the expression for G. So capital G is 40 minus 30e to the 1 minus 0.05 times 70, and this works out to be 37.5 tons. And then in C, we are told that there's a limit to the mass of gold that can be extracted, and we need to state this limit. So we simply consider the value of G as T tends to infinity. So as T tends to infinity, 30e to the 1 minus 0.05 T will tend to 0, because you've got e to some large negative power, and therefore we can see that g will be tending to 40, and therefore this limit is simply 40 tons. In question 4, we need to show that this equation here can be written in the form of tan theta is 2 root 3. So we start off with 2 sine of theta minus 30 is equal to 5 cos theta. I will be using the addition formula for sine A minus B. So it's going to be 2 brackets sine of theta cos 30 minus cos theta sine of 30 close brackets is 5 cos theta. Now we know that cos of 30 is root 3 over 2. So it's going to be 2 sine theta root 3 over 2 minus 2 cos theta. Now sine of 30 is a half, is equal to 5 cos theta. And therefore root 3 sine theta minus cos theta is equal to 5 cos theta, leading to root 3 sine theta is 6 cos theta. Now I will divide both sides by root 3 cos theta, so that the left hand side will give me simply a tan, and on the right hand side I will be having 6 over root 3. Now I can rationalize the denominator by multiplying by root 3 over root 3. So we get that tan theta is 6 root 3 over 3, which is simply 2 root 3 as required. And then in part B, it says hence or otherwise solve this equation here. So if we compare with the original thing, we can see that theta has been replaced with x plus 20. So I can simply say that since we've got theta to be x plus 20, then we've got that tan of x plus 20 is equal to 2 root 3. So my principal value is shift tan of 2 root 3, which turns out to be 73.8979. And therefore x plus 20 is 73.8979 plus 180k. I will deduct 20, so I'm leaving x on its own. X is 53.8979 plus 180k. If I put k to be 0, I get the first value to be 53.9 degrees. Remember, we are between 0 and 360. And if I put k to be 1, I get 180 plus 53.8979, which is 233.9 degrees. In question 5, the first part, we need to use algebraic integration to find the value of this integral. So I will start by writing this as the integral from 2 to 4 of 8 times 2x minus 3 to the minus 3 with respect to x. Now we've got a linear expression in the bracket, which means I can increase the power by 1. So 2x minus 3 to the negative 2. I divide by the new power, and I also divide by the derivative of the bracket. So the derivative of 2x minus 3 is simply 2. And I've got limits of 2 and 4. So this means I've got minus 2 over 2x minus 3 squared from 2 to 4. So I will start by substituting the upper limit, which will give me minus 2 over 2 times 4 minus 3 squared minus the lower limit substituted, which is minus 2 over 2 times 2 minus 3 squared. So this gives an answer of minus 2 over 25 plus 2, which gives me 48 over 25. In II, it's the integral of x brackets x squared plus 3 to the power of 7. So I will be using the reverse chain rule here. So it's the integral of x squared plus 3 to the power of 7 dx. So we notice that the derivative of x squared plus 3 is 2x. So what I will do, I will multiply by 2 and divide by 2 to counterbalance the effect. And therefore, now that I've got 2x being the derivative of the bracket, the reverse chain rule simply says that we increase the power by 1 and we divide by the new power. So it's going to be x squared plus 3 to the 8 over 8 plus c, which simplifies to x squared plus 3 to the power of 8 over 16 plus c, because it's an indefinite integral. In question 6, the first part, we need to show that this curve has a stationary point at x is root p over 2, where p is a constant to be found. So we start by differentiating. We have dy dx is 3 times the derivative of the inside, which is 2x, and the derivative of ln is 1 over, so 3 times 2x over x squared minus 5. And the derivative of minus 4x squared is negative 8x. Now a stationary point means I set the dy dx to be 0, so 6x over x squared minus 5 minus 8x is equal to 0, which means that we've got 6x over x squared minus 5 is equal to 8x. So I can cross multiply to get 6x is 8x cubed minus 40x. And then collecting everything on the right hand side, we get 0 is 8x cubed minus 46x. I will factor out the 2x, leaving me in the bracket with 4x squared minus 23, which means that either x is 0 or 4x squared is equal to 23, which means that x squared is 23 over 4, and x is the plus minus root of 23 over 4. Now, we have been told that this curve is defined for x being greater than root 5, so I reject the solution of x is 0, since x is greater than root 5, and I also reject the negative root, so I'm left with only the positive. So we've got x is root 23 and the root of 4 is 2. So the constant p is 23. In the second part, we are given y is 4x minus 12 sine squared x. We need to find dy dx and put it in this form, and then state the maximum gradient of this curve. So let's start by writing the expression for y. We've got y is 4x minus 12 sine squared x. So dy dx is 4 minus 12. Now we get the power down the 2. We deduct 1 from the power times the derivative of the bracket. Now this is 4 minus 12 times sine of 2x. So we've got the dy dx. And then for the maximum gradient, well, we know that sine of 2x is between 1 and negative 1. So negative 12 sine 2x will be between 12 and negative 12. So if I add 4, I can see that it varies between 16 and negative 8. And therefore, it's easy to conclude that the maximum gradient will be at 16. So maximum gradient is 16. Question 7, it's the mass capital M kilogram of a species of trees modeled in this equation, where r centimeter is the base radius of the tree. Now we are told that the base radius is 45 centimeters and we are asked to find the mass of this tree. So I will simply be substituting r is 45, so this leads to log of m base 10 is 1.93 log of 45 base 10 plus 0.684. Now the right hand side can be evaluated on the calculator, leading to log of m base 10 is equal to 3.8747 ... and therefore m is 10 to the 3.8747, which gives an answer of 7,500 kilograms to 2 significant figures. In part B, we need to show that the equation can be written in this form. So we need to find P and Q to three significant figures. So it makes sense to start with M is PR to the Q and take log base 10 of both sides. So this will be log PR to the Q base 10, which can be written as the log of P plus the log of R to the Q base 10. So we have log of M base 10 is log of P base 10 plus Q log of R base 10. And we also know we have been given that log of M base 10 is equal to 1.93 log R base 10 plus 0.684. So if I compare, I can see that the 1.93 must be the Q and the 0.684 must be the log of P base 10. So there it is, Q is 1.93, log of P base 10 is 0.684, and therefore we got that P is 10 to the 0.684, which gives an answer of 4.83. So the model is capital M is 4.83, R to the 1.93. In C, we are asked to interpret the value of the constant P, and we notice that when R is 1, then irrespective of the value of Q, capital M will be P. So in other words, the P we found, the 4.83, should be the mass of a tree having a base radius of 1 centimeter. So that's going to be our answer to part C. In question 8, we are asked to sketch the graph of arc sine a half x. Now we need to start by considering the effect of the half within the bracket with x. This means that we multiply x by 2, so it's essentially a stretch along the horizontal scale factor of 2. So bearing in mind the shape of arc sine x, we just stretch along the horizontal, and it should give us something like this. So the original arc sine goes from -1 to 1, so we go from -2 to 2. Now it is crucial here to note that at the origin over here, the gradient should not be 0. So we make a note that gradient at origin is non-zero, which means that someone who has drawn a curve that goes something like this will be penalized because they are suggesting that the gradient is 0 at the origin, which is not the case for arc sine. Now in B, we need to start with x is 2 sine y to show that dy dx is equal to 1 over root of a minus x squared. So let's start by writing the equation. X is 2 sine y, which means that dx dy is 2 cos y. Now I will draw a triangle here starting with x over 2 is sine y to put this in a simple right angle triangle. So if this is y, then the opposite is x and the hypotenuse is 2. Pythagoras gives me that the adjacent is 4 minus x squared square root, which makes cos y to be the adjacent over the hypotenuse. So I can go back to the x dy and substitute the cos y with 4 minus x squared square root over 2. Now the 2's will cancel out, and therefore I can now take the reciprocal to give me that dy dx is equal to 1 over 4 minus x squared square root. In part C, we need to find the equation of the tangent to C at P, at which point the y coordinate is pi over 4. So the curve was f of x, being arc sine over half x. We need to build a connection between these two, which it will turn out to be that they are essentially the same. So if we start with x is 2 sine y, then we can try to make y the subject. So x over 2 is sine y and therefore arc sine of x over 2 is equal to y. So we know that the derivative dy dx is 1 over 4 minus x squared square root. So I will use the fact that y is pi over 4 to find x and dy dx. So when y is pi over 4, x is 2 sine of pi over 4, which turns out to be root 2, and dy dx is 1 over 4 minus root 2 squared square root, which gives me root 2 over 2. So I've got a point, I've got the gradient of the tangent, so I will be using y minus y1 is mx minus x1. So y is root 2 over 2x. If I multiply root 2 over 2 times root 2, I simply get a value of -1. So -1 plus the pi over 4, which was on the left. And this completes the answer. In question 9, we've got a curve with this equation here, and we need to find f dash of x. So I will start by expanding the bracket. We've got f of x is x brackets x squared minus 4 e to the minus a half x. And I will expand to get x cubed minus 4x times e to the minus a half x. And in order for me to find the derivative, I will be using the product rule. So f dash of x, I differentiate the first and I keep the second, and then I keep the first and I differentiate the second. The derivative of e to the minus a half x is minus a half e to the minus a half x. So we have just found an expression for f dash of x. Notice we haven't been told to simplify this or put in a particular form, so we will score the 2 marks by simply stopping here. And then if we go to part B, we are told that the line L is a normal to the curve at O and meets the curve again at the point P. Now the point P, as we can see on the graph, it lies in the 3rd quadrant, and we need to show that the x coordinate of P is a solution of this equation. So, because the point of intersection is the origin, I will start by evaluating f dash of 0. So if we put 0 in place of x, we can see that we get minus 4. And this means that the gradient of the normal is a quarter. So the equation of the normal is y is a quarter x, as we know it passes through the origin. And at the point P, we've got the normal and the curve meeting again, so I can equate their y coordinates. So a quarter x is x brackets x squared minus 4 e to the minus a half x. So I will start by getting rid of the over 4, which means that x is 4x brackets x squared minus 4 e to the minus a half x. I will collect everything on the right hand side to give me 0 is 4x brackets x squared minus 4 e to the minus a half x minus x. And now we'll take the x out, so we've got x brackets 4 brackets x squared minus 4 e to the minus a half x minus 1, which means that either x is 0, which is of course rejected because that's the origin. We're looking for a point in the 3rd quadrant, or we have that 4x squared minus 4 e to the minus a half x is equal to 1. So this means that 4 brackets x squared minus 4 is e to the half x. I could expand the left hand side to get me 4x squared minus 16 is e to the half x. So 4x squared is 16 plus e to the half x. I can take the 4 on the right hand side to give me x squared is 16 plus e to the half x over 4. And now we'll take the square root. Obviously, I'm looking for an x coordinate which is negative, as we are lying in the 3rd quadrant. So strictly speaking, I could have said plus minus 16 plus e to the half x over 4. And now I will explain that at p, x is negative. Therefore, we have that x is minus the square root of 16 plus e to the half x over 2, which is simply the square root of 4, as required. And then in part C, we need to use the iterative formula here to find the value of x2 and the x-coordinate of p, both to 4 decimal places. So if I start with the x1 being negative 2 as instructed, I can plug the iteration formula on my calculator and I get that x2 is minus 2.0229. Now, repeating this process, keep pressing the equal button on my calculator. I keep doing that until the answer stabilizes, and we can see that after a few presses of the equal sign, we get that x is minus 2.0226 to 4 decimal places. In question 10, we start by being asked to show that 1 plus 2 cos 2x all squared can be written in this form. So I will actually start by expanding. We've got 1 plus 2 cos 2x all squared. So this is 1 plus 4 cos 2x plus 4 cos squared of 2x. Now I will write this as 1 plus 4 cos 2x plus 2 times 2 cos squared 2x. Because we know of an identity, we know that cos of 2 theta is 2 cos squared theta minus 1, which means that cos of 4 theta is 2 cos squared 2 theta minus 1, and therefore I can replace the 2 cos squared 2x with cos of 4x plus 1. So if I expand this, I get 3 plus 4 cos 2x plus 2 cos 4x. In part B, we need to find the shaded area in the graph here using algebraic integration. So we're looking at this area here. We need to start by finding the value of a, and the value of a can be found by setting y is 0 and picking the second positive solution, because the first one will be this one here. So let me start by setting y to be 0, which means that I need to solve 1 plus 2 cos 2x is 0. So we've got that cos of 2x must be minus a half. My principal value will be shift cos of minus a half, which is 2 pi over 3. Remember that in integration we are always in radian mode. So 2x is plus minus 2 pi over 3 plus 2 pi k. I will divide throughout by 2 to get that x is plus minus pi over 3 plus pi k. And we can see that the first two positive solutions are pi over 3 and 2 pi over 3, and therefore the value of a will be 2 pi over 3. Now this means that the area we're trying to find will simply be the integral from 0 up to 2 pi over 3 of 1 plus 2 cos 2x all squared dx. And now I'm using the first part where we express this as 3 plus 4 cos 2x plus 2 cos 4x dx. And this is actually giving me 3x plus 4 sine 2x over 2 plus 2 sine 4x over 4, with the limits being 0 and 2 pi over 3. Now the 4 with the 2 leaves me at 2, the 2 with the 4 leaves me at 2 in the bottom. So I will now substitute the upper limit. So this is giving me 3 times 2 pi over 3 plus 2 sine of 2 times 2 pi over 3 plus a half sine of 4 times 2 pi over 3. And if I substitute the lower limit of 0, all of these will give me 0. So the contribution from the lower limit is simply 0. So this is 2 pi plus minus root 3 plus root 3 over 4, which simplifies to 2 pi minus 3 root 3 over 4, which is the final answer.